Please welcome Google Cloud Vice President and General Manager, AI and Computing Infrastructure, Mark Lohmeyer.
All right. Well, hello, everyone. It's really great to be here with all of you today. My name is Mark Lohmeyer, and I lead the AI and Computing Infrastructure product team at Google. So last year when we were here, we talked about conversing with AI. And to make it fun, I brought my dog Chewy onto the big screen, and we showed off our latest Gemini and Nano Banana image models. And we watched him transform into a tech influencer, as you can see here, through the power of prompts and pixels. And this was really the chat phase, right? It was fun, it was visual, it was conversational. But if you fast forward to Chewy now, technology has rapidly advanced. So thanks to Project Genie, which we introduced earlier this year, he's now embodied in a real-time, interactive virtual world, navigating his terrain. So we're moving past AI that just answers questions or generates images. We've entered the agentic era, where AI reasons, navigates, and takes action. But the magic you just saw can be incredibly expensive and complex to build. And we can't solve tomorrow's agentic challenges with yesterday's fragmented architecture. If your best engineers are stuck stitching together disparate components, you'll end up paying an integration tax. So to innovate quickly and cost effectively, you really need a unified system. And this is where Google Cloud stands apart, because we co-design and integrate across the entire AI stack, starting with the silicon all the way up to the application. And it comes down to 4 things that only Google can deliver. First, deep AI expertise. You aren't just renting someone else's servers. You're leveraging that same innovation engine that runs all of Google. We take the breakthroughs from DeepMind, which is led by world-renowned researchers, including Nobel Prize winners, who are working together with our world-class infrastructure engineering teams, and we turn these breakthroughs into enterprise-ready products that your business can use today. Second, our full-stack advantage. We co-design across every layer, from our infrastructure to our models to our data cloud, all the way up to the applications. And this deep integration allows you to deliver with a velocity that a fragmented stack just can't match. And because we offer this integrated experience both for our own custom TPUs as well as the latest NVIDIA GPUs, you have the ultimate flexibility to meet the needs of your business. Third, we're open at every level. So integrated doesn't need to mean closed. Think of this as a yes and strategy. So yes, our stack is engineered to work together, and it's open at every layer, giving you an uncompromising choice. So it's designed to plug into what you already use, and of course it works with both Google Gemini as well as a broad range of other leading third-party and OSS models. Fourth, reliability and security. So we provide the same battle-tested foundation that keeps Google's global products, which are used by billions of users around the world, online every second of every day. And you also get integrated security to help ensure that you never have to choose between moving fast and staying safe. Ultimately, it's really our deep engineering culture that helps ensure that you get reliability and security that's built in, not just bolted on. So taken all together, this is the Google advantage. So now, let's dive in to the infrastructure that powers all of this in more depth. So a lot has changed since we were here last year. As you heard earlier, we're witnessing a fundamental shift. AI is moving from prompt and response to intent and execution. It's moving from linear inference to multi-step reasoning loops. Think about that shift for a sec. In the agentic era, one intent can trigger a chain reaction. An agent breaks down your intent into multiple tasks, and then multiple agents will work on these tasks, each preserving state as they work together towards this end goal. And along the way, those agents can use reinforcement learning to test the results in real time to improve the model. So this isn't just faster chat anymore. It's a massive, massive scaling of intelligence. And if you think about it like a single interaction that once used maybe 1,000 tokens, now it's going to use 20, maybe 50 times that amount as the multiple agents think, collaborate, and act together on your behalf. And so while this unlocks major, major new capabilities, if you try to do this on yesterday's architecture, it can quickly lead to poor performance and spiraling costs. So you need a computing infrastructure that helps you scale intelligence and automate actions without also scaling your costs exponentially. And so the agentic era drives really fundamentally different requirements for the infrastructure in 5 key dimensions. First, agents must be smarter, trained on vast, vast data sets with outputs that are continuously tested in real time. Second, they must be faster, reacting to users and actually other agents in real time. Third, they must be massively scalable, spinning up thousands of agents potentially in seconds. Fourth, they must be reliable and secure by design. And last, but definitely not least, they need to be radically cost-effective to scale. And you can't meet those 5 core requirements with yesterday's architecture. So to meet this moment, we're taking another huge leap forward in our AI infrastructure innovation. Our AI hypercomputer is AI-optimized infrastructure that's built specifically for the agentic era. It powers Google's models and AI services, as well as leading organizations around the world, many of which you see here. You know, the AI hypercomputer brings together first purpose-built hardware, combined with open software and flexible consumption. And as TK and Amin mentioned earlier in their keynote, we're introducing new capabilities at every level of this stack to help you deliver on agentic experiences that are smarter, faster, while also being reliable, secure, and cost-effective. So let's go deeper now. The foundation of AI hypercomputer is compute. Google's been investing now for more than 10 years in TPUs. And this year, we're super proud to announce 2 major new systems, TPU-8T and TPU-8I, each of which is purpose-built for the unique needs of the agentic era. TPU-8T, excited about that. TPU-8T, it's our powerhouse that's optimized for training and high-throughput workloads. And TPU-8I is our breakthrough platform that's optimized for ultra-low latency inference and reinforcement learning at the lowest possible cost. So let's explore each of these systems further now. So when it comes to training trillion parameter models, you need a system that knows how to scale. And TPU-8T is optimized for training and scales far, far beyond anything we've ever built before. You know, the system, it starts with the chip, and the chip that powers TPU-8T is pretty amazing. You know, we've increased the performance and the model flops utilization, or MFU. We've done this by moving that block scale multiplication into the matrix multiplication units, or MXUs, while also enabling native FP4 support. TPU-8T is also the first TPU that's built on Google Axion-based ARM hosts, which further increases system efficiency and performance. So it starts with these silicon elements, but it really, really scales by leveraging our breakthrough network interconnects and specialized memory architectures that go together with this. As part of this, we've doubled our interchip interconnect, or what we call ICI, to 19.6 terabits per second of bandwidth per chip. And then we use that network, that network to connect 9,600 TPU chips into a single superpod. This has over 2 petabytes of shared high bandwidth memory, delivering 121 exaflops in a single superpod. That's nearly 3 times the performance of our prior TPU generation just a year ago. This means that our customers can build and run the most complex models in a single massive pool of compute and memory. And one of the best parts here is that we've achieved these amazing leaps in performance and scale while also making the system much more efficient. In fact, it delivers up to 2 times better performance per watt than the prior generation. So TPU-8T is where the world's most sophisticated AI becomes a reality, faster and more sustainable than ever before. And ultimately, this is a platform that's designed to accelerate innovation. It makes it possible to take training jobs that previously might have taken months down to weeks, or experiments that might have taken weeks down to days. This enables us and all of our customers, all of you, to iterate and innovate faster than the competition. But we didn't actually stop at a single superpod. When we connect these new systems together with our new Virgo network, the scale becomes truly staggering. The Virgo network can connect 134,000 of these TPUs in a single seamless cluster, filling literally an entire data center. Virgo uses a non-blocking collapsed fabric architecture, which eliminates the traditional choke points of massive clusters like this. Virgo also has 4 times the bandwidth per TPU of the prior generation to ensure that the data flows quickly across that entire massive footprint of TPUs. But that's not all. Using our Pathways software and in conjunction with the JAX framework on top, we can scale to over 1 million TPU chips in a single logical training cluster. So, pretty awesome. So this isn't about just building for the models today. We're providing the massive infrastructure, scale, and performance that's required to power the next generation of agentic AI. So if you have the ambition to imagine it, this is a system that can actually build it. Now, a compute cluster of this size also needs an immense amount of data to keep it well fed. And so this requires a new type of storage that can actually keep up. So today I'm pleased to announce our managed Lustre service supports 10 terabytes per second of bandwidth. This is incredible performance, and it's enabled underneath the hood by our new network-optimized C4NX compute instances and our hyperdisk exapools block storage, the whole thing being underpinned by our titanium offload architecture. Managed Lustre also supports direct access between the storage and the accelerators with something called TPU Direct. This uses RDMA, remote direct memory access, to bypass the CPU, so to further increase the latency and throughput. So 10 terabytes per second, just to put that in a frame of reference, it's 10 times faster than what we could do last year, and it's up to 20 times faster than other hyperscalers today. At the same time, we're also increasing the storage capacity by 10 times to a pretty staggering 80 petabytes. So in this market that's moving so quickly, the AI model that learns the fastest from the most data, ultimately it's going to win. We're also really excited to announce the GA of rapid buckets on Google Cloud Storage. With sub-second random read-write latency, it enables incredibly fast training checkpoints and recovery. So the result of this is that those really valuable accelerators, they can keep cranking at full utilization, close to 100% utilization, which really accelerates your time to train the model or update models and make the best use of those very valuable resources. Now, we also know that for many of you, integrated must also mean open, as we talked about before. And it's also true in this space, right? You have existing investments and partners that you trust. So for customers that want to bring their own parallel file systems, like VAST Data or SciComp, we're launching the Z4M instance this year. Each Z4M instance can scale to a massive 168 terabytes of local SSD capacity, deployed in high-speed RDMA clusters with thousands of machines. This gives you the raw power of the Google stack, combined with the specific storage partners that you already trust. So together, Managed Lustre, Rapid Buckets, and Z4M, it provides the industry's leading portfolio of storage options that enables the most cutting-edge AI applications. Now, let's talk about our second purpose-built system, TPU-8i. TPU-8i is optimized end-to-end for inference and reinforcement learning. In the agentic era, intelligence is really only half the battle. Once an agent knows what to do, it has to do it, and it has to do it really fast and really cost-effectively. TPU-8i is how we make instant a reality. Each TPU-8i system has been engineered to eliminate that traditional waiting room. So let's go through the pieces here. On the chip itself, we've tripled the SRAM versus our previous generation TPU to 384 megabytes. And at the same time, we've also increased the high bandwidth memory by 50% to 288 gigabytes. This is key because it enables you to keep more of the agent's working memory, the KV cache as it's called, right on the chip, not in a separate cluster or system. Beyond this, the TPU-8i's new collective acceleration engine, or CAE, offloads core operations like all gather from the main processor. This further reduces the on-chip latency by 5 times. In addition, to give every user request dedicated CPU resources, we've paired the TPU-8i with double the amount of physical CPU hosts, which are now powered also by our Google-designed Axion ARM CPUs. Axion, which supports NUMA isolations optimized for efficient single-threaded performance per core, which is really, really perfect for these agentic workloads. Modern MOE models require those accelerators to talk constantly and synchronously to each other. And so to accelerate this, we doubled the ICI bandwidth here as well to 19.2 terabits per second. And really important, we've reduced the network diameter, the maximum number of hops from one side of the architecture to the other, by more than 50% with our new board fly architecture. Taken all together, all of these agent-first architectural advances, they enable TPU-8i to deliver up to 80% better performance per dollar for low latency inference and reinforcement learning compared to just our prior generation. Think about what that means for your business. It's a fast, interactive experience for agent-based voice interactions, automation, coding, research, so many other AI-powered applications, while also at the same time being able to serve 2 times more customers at the same cost. But we're going even further to increase agent performance. In addition to the increased onboard KV cache in TPU-8i, we're also going to be releasing a high-performance, dedicated KV cache storage service later this year. This new solution will support both TPU and GPU-based systems at near line rate, and also will support KV cache tiering and software through GKE and the LLMD software. This will further improve inference response times while also optimizing costs, even as the number of agents scales. So we're really, really excited about these new TPU-8 systems and how they're going to power training, RL, and inference in the age of agents. But crucially, this level of innovation isn't limited just to our own TPUs. To give you the ultimate flexibility, we're also further expanding our partnership and solutions with NVIDIA. For every new generation of NVIDIA GPU-based platforms, we collaborate closely with them to co-design, integrate, and deliver as a highly reliable service within Google Cloud. For example, we'll be among the first hyperscalers to deliver NVIDIA Vera Rubin GPUs as a cloud service later this year. This new product, A5X, is powered by NVIDIA Vera Rubin NVLink 72. A5X will also utilize Google's new Virgo network that I talked about before, here scaling up to 960,000 GPUs in a multi-site cluster. So massive scale. In addition, we're co-engineering the open source Falcon networking protocol with NVIDIA via the Open Compute project. And A5X is going to implement a variety of technologies from Falcon, really pushing the frontiers of reliable transport protocols. Our collaboration with NVIDIA is going to enable truly unprecedented scale, efficiency, and reliability for the most demanding agentic workloads. And we look forward to making it available to customers who have really optimized for NVIDIA's ecosystem. So to learn more about how a customer is using and is benefiting from the AI hypercomputer today, let's hear next from Thinking Machines Lab, which built their foundation model and their first product called Tinker on Google Cloud. And please welcome me in joining Mile Ott, founding researcher at TML, to the stage. Hey, Miles.
Hey, how's it going?
Great to see you. Great to see you. Thanks for joining. So thanks for being here. Yeah. So maybe tell us a little bit about Thinking Machines Lab and your approach overall to making AI useful to everybody.
Yeah, really excited to be here with you all. So Thinking Machines Lab is an AI research and product company on a mission to give everyone the knowledge and tools to make AI useful for their unique needs and goals. We released our first product about 6 months ago called Tinker, which is a state-of-the-art fine-tuning and post-training API. Tinker actually started as an internal project that we built to accelerate some of our own research that we decided to share openly when we realized one of the biggest challenges people face when customizing AI models is managing the infrastructure and complex software systems required for modern reinforcement learning. Tinker abstracts users from all of this complexity by managing the infrastructure and even reduces costs through features like multi-tenancy, and auto-scaling. Since we launched, we've seen rapid adoption across both AI native and enterprise users, with use cases ranging from financial forecasting to custom coding agents and even more scientific applications like mathematical theorem proving. And of course, as you might have guessed, Tinker runs on Google Cloud.
Excellent. So we love that part. So since you brought it up, since it runs on Google Cloud, maybe talk a little bit about how does that benefit you across both training and serving together on the cloud?
Yeah, it's a great question. So with reinforcement learning, we're now combining two traditionally separate workloads of training and inference into a single workload. And by having a single Google Cloud environment, we can now optimize this workload end-to-end for efficiency. For example, one of the most common operations that we do in reinforcement learning is weight transfer, where we copy the updated model weights from the trainer to the samplers. Using Google's really fast back-end RDMA network with speeds up to 800 gigabits per second per GPU, we can now do that weight transfer in just a handful of seconds, even for our biggest mixture of experts models, and in under a second when using more performant, parameter-efficient approaches like LoRa. Besides efficiency, I think another really big benefit of running Tinker on Google Cloud for us has been that it's just streamlined our security strategy by giving us the tools and controls we need to safeguard our customer data and models, which is just incredibly important.
Fantastic. So, Mile, I know you've been leading TML's infrastructure team from day zero, basically. So I'd love to hear a little bit more about your philosophy here for building out that team and Google's role in maybe helping there a little bit.
Yeah, at Thinking Machines, we view infrastructure as a competitive advantage. The space moves, as faster than ever, and having reliable infrastructure is really key to our success. At the same time, we're also a pretty small team doing what often takes many more people at bigger labs, and so we've had to be really strategic and disciplined about deciding which parts of the stack we build ourselves and which parts we outsource to close partners. GCP has been a really fantastic partner in that way because we've been able to leverage best-in-class supporting services like GKE, which we've successfully scaled to many thousands of nodes, and GCS, which has given us performant and dependable storage at scale, especially when combined with some of the newer offerings like Rapid Cache, which gives us this really high throughput, low latency in-zone cache for some of our largest and most demanding training workloads. Ultimately, having these dependable primitives just lets us focus on the more unique aspects of the work we do, like our post-training research and building products like Tinker.
Fantastic. So maybe before we wrap here, give us a sense of what's coming next. What's exciting to you going forward? Yeah,
there's a few things. So first, I think reinforcement learning is just going to be critical for adoption of AI technology, since it lets us take these general models and adapt them to new contexts and environments. So we just expect to see a lot more folks using RL over the coming years. A second thing I'm really excited about is this shift from more kind of stateless transactional AI systems that we see today to more stateful, persistent AI systems that learn and adapt as people use them. Ultimately, Tinker is built for both of these trends, so we're providing a platform that supports training and serving simultaneously in a live product. So really excited to be part of the industry's transition and adoption of RL and more stateful AI systems, and of course, to continue to scale and grow on Google Cloud.
Excellent. Well, thank you so much for being a great partner. Really appreciate it.
Thank you.
Thank you so much. All right, so whether it's TPUs or GPUs, we're not just shipping the hardware, we're shipping optimized outcomes. And crucial to enabling these outcomes is how we deliver and integrate OpenML software and orchestration capabilities with those underlying purpose-built hardware platforms. This can really help accelerate your time to results and help ensure that your innovation goes into innovation, not integration. So let me now share a little bit more on these powerful new software capabilities. We'll start with some big news that changes the game for your development teams. Today, we're excited to announce the private preview of native PyTorch support for TPU. For the tens of thousands of developers that are already building and serving models on PyTorch on GPUs, it just got a whole lot easier to take advantage of TPUs. You can now bring your research teams and your models to TPUs exactly as they are, with full native PyTorch support, including features like eager mode. And this isn't just an isolated update. When you combine this with our robust support for VLLM and SGLang inference engines on TPUs as well, we're sending a pretty clear message that Google Cloud is committed to openness and customer choice, making it easy to use GPUs or TPUs or use them both. based on whatever's the best thing for your team, for your business, or for your models. Next, we're pushing the limits of software performance and scale to match our silicon performance. For many years, Google Cloud has been leading the way in Kubernetes for cloud-native workloads. Now we're transforming Kubernetes to be an orchestration engine for agent-native workloads. This is particularly important to deliver those dynamic inference experiences that we were talking about before and accelerate those RL loops at the lowest possible cost. To do this, we've optimized every millisecond across the stack. Models now load 5 times faster with our AI model streamer and GCS rapid cache. Nodes start 4 times faster, and pods start up to 80% faster. These performance enhancements mean that when a surge of agent requests hit, you can instantly scale up and serve your users with a great experience. Last year, we also introduced the GKE Inference Gateway to solve the complexity of disaggregated serving and model-aware load balancing. This solution is now powering our Gemini Enterprise Agent platform, and it's enabling customers like Technology Innovation Institute. But this year, we're making the Inference Gateway even smarter by using machine learning to make even more intelligent routing decisions. Inference Gateway's new predictive latency boost cuts the time to first token latency by over 70%. This predictive latency boost replaces heuristic guesswork with real-time, capacity-aware routing, no manual tuning required. In the agentic era, lower latency means more natural voice conversations. That means faster code refactoring, and so much more. Every millisecond saved is a competitive advantage gained or a new delighted user. So we're excited by all these performance improvements, but we also wanted to ground these in capabilities in real data. That's why we're excited to introduce Prism. This is a new public performance analysis tool from the LLMD project where anyone can review and evaluate community-driven benchmarks based on real-world traffic and performance for open-weight models. These benchmarks will be updated daily, and customers can actually use a clone and run feature to validate these benchmarks directly in their own environment. So when it comes to agents, inference performance is a really important factor. Spent a lot of time talking about it, but it's only one of several new requirements. As I said earlier, in addition to being faster, agents also need to be secure by design, scale rapidly, and be cost-effective. That's why we're excited to introduce GKE Agent Sandbox now in preview. This is the first and only managed agent sandbox service amongst hyperscalers. It's designed to help secure and scale agents cost-effectively. So let's walk through the capabilities in more detail. First, if you think about it, agents are inherently trustworthy. They're frequently executing LLM-generated code. They can act on arbitrary content on a web page. They can do so many things. So to provide a secure execution environment, GKE Agent Sandbox now incorporates gvisor. gvisor is an open-source container runtime that can isolate agent activity at the kernel, storage, and networking level. Google has invested nearly a decade building gvisor, and it's already being used extensively by leading AI labs around the world. Second, many agent use cases, such as interactive coding and personal assistance, require massive scale and low latency execution. So to address this, Agent Sandbox manages a warm pool of sandboxes at the ready. This enables you to provision 300 sandboxes per second per GKE cluster with sub-second time to first instruction latency. This means you can launch tens of thousands of agents quickly and meet hundreds of thousands of concurrent user requests or sessions per cluster. Finally, agent sessions can last for days, but much of that time is actually spent idly, waiting for tools or other agents or maybe even humans to actually respond. So Agent Sandbox is designed to suspend resource consumption when an agent is idle and then resume instantly when it needs to act. This dramatically reduces the compute costs while still delivering really, really great performance. Customers like the popular vibe coding platform Lovable, they're already benefiting from the Agent Sandbox capabilities in production. And you can see their quote here. Now, interestingly, agents in RL don't run just on GPUs and TPUs. They also require CPUs. They require those CPUs for orchestration, for evaluation, for tool use, and so much more. So we're doubling down on our Google Compute Engine portfolio as well. our recently announced Axion-powered N4A CPU instances deliver outstanding price performance, and they're ideal for agents and reinforcement learning. In fact, GKE Agent Sandbox with the Axion N4A compute instance offers 30% better price performance than agent workloads on other hyperscalers. And it's not just ARM-based instances that are relevant for agents. Google Compute Engine offers a portfolio of x86-based CPUs from Intel and AMD that are optimized for the broadest range of agent and reinforcement learning use cases, including things like nested virtualization, agent orchestration, RL reward calculation and evaluation, even lightweight inference. Co-design and integration of hardware and software are driving impact across our entire portfolio. So whether you're using TPUs or GPUs or CPUs or all of the above, we're radically simplifying and scaling our powerful AI infrastructure. According to IDC, Google's AI hypercomputer reduces deployment times by almost 50% and increases IT productivity by 55%. That means your teams, your engineers, can spend more of their time on innovation instead of just integration. So as you can see, the AI hypercomputer is all about control and flexibility. You get to optimize your performance, you get to squeeze out every last bit of efficiency and control your AI spend at the most surgical level. It's a great model for leading labs, model builders, AI natives. And I know some of you want to be under that hood, but there are many others of you that might have a different mission. You want all that power while focusing full-time on customizing existing models and enabling agents. You want to be the architect. So to meet this need, we take that really powerful infrastructure and we make it simple and fully managed. With managed training in Gemini Enterprise Agent Platform, you can access, build, and customize everything from our state-of-the-art Gemini models to a full range of popular open source models. Let's break down how. First, for your most demanding mission-critical workloads, we offer enterprise-grade training with resilient infrastructure. Our training clusters deliver uninterrupted, large-scale training by automating the deployment of those AI hypercomputer clusters designed to maximize the overall goodput of the system. Second, we enable agile AI development. So for teams who need to move fast, our serverless training and managed tuning allows for rapid model adaptation. This includes efficient methods like LoRa and QLoRa that save on both cost and memory. And we're taking it a step further with reinforcement learning. With our managed RL API, you can define any reward function in Python and use that to train open source models. Or with RL for Gemini, you can encode your specific business logic directly into our frontier Gemini models. Fourth, we provide a seamless transition from training to serving. The real power is in the integration across that entire life cycle. The agent platform unifies everything from model discovery in the model garden to connecting your corporate data to training and tuning, and finally to optimize serving. This single ecosystem enables you to deploy reliable, context-aware agents to dedicated endpoints, accelerating your path to ROI. This is why leaders like Adobe, CrowdStrike, Salesforce, and so many others trust the Gemini Enterprise Agent Platform to build their next generation of AI. Enterprises are using AI agents across software development, operations, marketing, support, and so much more. As a result, they need a full stack of cloud services to enable all of these solutions. So to show you what this looks like in practice, let's hear next from a customer that is using that entire stack, Micron.
I'm Koen de Bakke, Corporate Vice President of Smart Manufacturing at Micron, and I lead an organization called Smart Manufacturing and AI. In semiconductor manufacturing, precision at scale is the baseline. If you look through our front-end manufacturing, which is our wafer manufacturing, it's about 1,500 production steps. To achieve this, we rely on Google Cloud's end-to-end AI-optimized stack. It starts at the base layer, infrastructure and chips. Google provides the scalable compute and storage muscle on a daily basis. We will ingest about 75 terabytes of new data coming from all the equipment tools and the processes that we run. That means we have about 460 million control points that we look at any moment in time. And we capture about 100 million images on a monthly basis that we'll look at in terms of inferencing. Moving up to data and analytics, a couple of years ago we moved from Hadoop to Google Cloud. not just for kind of the scale of it, but also all the AI services on top of it, which gave us clean, consolidated data movement we needed to scale. With our data structured, we are tapping directly into Google Cloud's cutting-edge research and models. One of the areas of how we use AI and kind of vision capabilities, see whether any small defects are occurring throughout the production process. We use Nano Banana to generate synthetic images, and that really helps us to accelerate the training, and we can put our controls much quicker in place. We're actively transitioning to Gemini 3 supervised fine-tuning to drive higher performance in our multi-class models. The platform and protocols layer built on Vertex AI allows us to successfully deploy and manage over 200 models dedicated to defect detection. Our partnership with Google and overall deployment of AI in Micron has really helped drive AI productivity for all of our employees. This translates to 327 large-scale production solutions used by thousands of users daily to improve our yield, diagnose and troubleshoot quality issues, and maximize output. Google Cloud isn't just infrastructure, it's the complete stack powering our competitive edge.
All right, great to see. But the agentic era doesn't stop in the digital world. The same principles are giving rise to another frontier, physical AI. Physical AI is a branch of artificial intelligence that enables machines to perceive, interact, and understand the physical world. And it looks like Chewy 2.0 is ready for his third act here. So we've seen him as a 2D image, we've seen him navigate a virtual simulation, and now he's here, fully embodied. Hey, buddy, it's good to see you. Glad you made it here safely. Actually, I must admit, he's a little bit less cute than the real Chewy, so we're going to call him Spot from here on out. Spot is a marvel of engineering from our partners at Boston Dynamics. And what makes this Spot so special is that he's been custom built for high-end videography and trained entirely within Google Cloud. So let's give a wave to the future. All right, awesome. So you're looking at a first-person view of the room through the sensors of a machine that doesn't just see us. It understands exactly where it is. And I think Spot can definitely see this room better than I can with all these bright lights. But what you see on the screen is only half of the story. To make this level of autonomy possible, Spot and other physical AI solutions need more than just hardware. They need a massive, intelligent backbone. These solutions need cloud infrastructure that spans from training to physics-based simulations to responses, real-time responses in the real world. So when we apply reinforcement learning to physical AI from the robot, we take the raw experience from the robot, we run it through millions of physics-based simulations in a virtual twin environment, and then we send that optimized policy back to the robot at the edge. It's not just a linear path. It's a constant cycle of sensing, simulating, and adapting. So, to explore how physical AI is transforming the front lines of the creative industry, please join me in welcoming the CTO of the world's largest advertising agency, WPP, Stefan Pretorius. Stefan, great to see you. Thank you for being here.
Thanks for having me.
Fantastic. So first of all, thank you for bringing Spot here with us today. And maybe tell us a little bit more. How is WPP using Spot and physical AI?
Hey, Spot. How's the Wi-Fi looking today? Good, yeah. Thanks, Mark. Look, so at WPP, innovation is really in our DNA. And we have, over the last couple of years, innovated an innovative agentic marketing platform called WPP Open, which is based largely on Google Cloud, Vertex, and Google's Gen AI models. But one of our biggest business units is production. It's a billion-dollar business. And this is really where physical AI comes to life. So we use Spot in capturing scenes and sets. And our partnership with Boston Dynamics exemplifies this work, as you can see here on the screen, culminating in a shoot that we did with our Atlas humanoid robot in the studio in Boston. And so this commitment to AI is really what differentiates WPP. It's at the heart of what we do, and it's the unifying force that brings together our diverse global talent in a single powerful AI platform, empowering them to conceive and execute truly innovative, amazing, creative work.
So yeah, thanks for sharing that. Fascinating. It'd be great to maybe now walk through the technology behind Spot and how WPP enabled these core capabilities. So let's take a look at the steps of reinforcement learning applied here for physical AI. RL starts with what we call the capture phase. We capture the physical world to create a high-fidelity digital twin. This is an environment where an AI can practice 1,000 lifetimes in a few hours. So Stefan, how does this work with Spot and WPP specifically?
So in production, it's really all about precision. And we use this capture step to capture a scene, a field, a sand dune, that we can then train Spot on to master the environment before we ever set foot in that environment. So Mark, what is the next step then after the initial capture?
Yeah. So if you think about having mastered that, let's say those core skills, we now need to validate the agents or the robot's performance against a wide variety of diverse environments and potential real-world scenarios.
Yeah.
And this is where the simulate phase comes in. So here we're using generative AI models like VO, Nano Banana, Genie 3 we talked about before, to build these high-fidelity simulations where robots can learn from real-world scenarios, but do so safely and at scale by doing it digitally. So in this case, how are you adding that context for WPP?
Yes, I mean, it's really the way to think about it is that that rich generated AI context is the difference between a robot that can just walk around and move in its environment and a robot that can create. And so with these generative AI tools, particularly VO, we can simulate lighting conditions, camera angles, and even impossible tracking shots in a safe virtual sandbox. And then Mark, the next step after that.
Yeah. So once we've updated that model, we're taking that perfected intelligence, let's call it, and we're transferring it directly onto the robotic systems. And as you were talking about before, this isn't just about making the robots move. It's about making them useful in environments where humans shouldn't go, or maybe in some cases, can't go. So, and I think you might have a good example to show us of this here.
Exactly. So talking about environments where humans shouldn't go, what you're seeing on the screen now is footage of this Spot in Google's lab, filming the very TPU hardware that Mark was discussing earlier. So Spot was able to navigate into these tight spaces and awkward positions that would be difficult for a human operator to reach and frankly, possibly illegal or a security risk. and so we're using this continuous learning loop on Google Cloud to give Spot the ability to perform anywhere. And that's really the breakthrough for us, because when you close the loop, the robot isn't just following a pre-programmed path, it's using that cloud-mastered precision to react to the unpredictable nature in a live environment.
Wow, that is really amazing. And behind the scenes, Google Cloud is providing the AI infrastructure of NVIDIA GPUs and Google TPUs to power all of this, everything you're seeing here. It's the combination of the world's most advanced models, like Gemini Robotics, the industry's most powerful sandbox, to enable these real-world physical AI capabilities.
That's fantastic. So Mark, before we go, I think we need one more photograph of the Spot. So should we do it?
I couldn't agree more. Let's give it a try.
Cool. Let's get into position.
All right.
So on 3, 1, 2, 3, TPU, okay? All together. We're going to get into position. Okay, get a bit closer. Okay. All right. 1, 2, 3, TPU.
All right, that's a winner.
Excellent.
All right.
Thank you, Mark.
Thank you, Stefan. Fantastic. All right, thank you, Stefan, and thank you, Spot, as well, for being with us here today. We'll let you go back to your resting spot. All right, let him make his way over. So, leading in physical AI requires infrastructure that seamlessly bridges the digital and physical worlds. And so I'm really excited to share the Google Cloud Physical AI Reference Architecture. This is a blueprint that brings together GKE, GPUs, TPUs, CPUs, data services, everything that we talked about before, giving you a clear path to building your own physical AI solutions. You can find this, along with demos, use cases, and so much more at our new Physical AI page right there. So everything we talked about today, from the raw power and the ultimate control of the AI hypercomputer to the managed simplicity of the Gemini Enterprise Agent Platform, it all comes together here. The Spot robot learned its task not in a factory, but in a digital twin world, running millions of simulations on our cloud. It was trained on that same infrastructure that powers Thinking Machine Labs, and it's refined with the same tools used by Micron, and deployed with the same physical AI principles that you heard Stefan from WPP talk about that they use to automate their creative work. So whether you're building digital agents to transform your customer experiences or empower your employees, or you're building physical agents like we saw to revolutionize your operations or other things, the path is the same. It starts with an idea. That idea is perfected in the cloud and then deployed to the world at scale. The agentic era is about amplifying human creativity and potential. It's about taking your boldest ideas and giving them the power to act, to build, to create. We've built the platform. The tools are in your hands. Now we can't wait to see what you're all going to build with it. Thank you all.